So if you already understand the SharePoint server object model, then really you already understand a lot of the client object model. There's a close correspondence between the server-side classes and then their client-side alternatives. So you can see here, all you really need to do is just remove the SP from the class name in many of the cases. And this comes in 3 versions, so there's more than 3 versions, but there's managed code clients, and then there's the Silverlight Windows Phone clients, and then the JavaScript libraries. So managed code, when I say that, I'm talking .NET 4.0, 4.5, and then there's the .NET code specifically targeted for Silverlight and then also for Windows Phone, and then the JavaScript libraries that also abstract away the calling the web services. So there's a client-side object model written in JavaScript that you can include and make JavaScript calls. Or alternatively, if you didn't want to do that, you could, in your JavaScript, you could just use jQuery and just make regular AJAX calls. That's available too. So what we're going to do now is we'll build a .NET console application that uses the client-side object model. Okay, I'm going to create a new project in Visual Studio, and we're just going to create a console application. Oops. And I'm going to call it console client. Click OK. And first thing I need to do is I need to add references to the right libraries so we can use the client-side object model. I'm going to add those references now, and probably going to have to browse for them. So let's just browse. We'll browse to. We're in the ISAPI folder of the 15 Hive, and we want Microsoft.SharePoint.client and Microsoft.SharePoint.client.runtime. We'll add both of those. And we'll add the using statement on the top here so we can use the namespace. And let's go ahead and create a client context. And for now, we'll just put in the URL of our server that we've been using. SP server, okay. Now I'm going to get an instance of the web from the client context. So right now, oops, forgot to put equals in there. So right now that web is not going to have any information. We need to load it from the server. So I'm going to tell the context to do a load, and we want to load that web. Then we can actually access properties. Now before we do that though, so we're telling the client runtime to load the web. Now we need to actually cause the runtime to call the server and then populate the web. So we'll call context, execute query. Execute query that's when we're making that call going across the wire. So now that we've done that, I'll just do a little console.writeLine. client.title. And I'll just put in a read line just so it doesn't exit right away. And I'm going to go ahead and press F5 and run this. And you can see it did read the team site. If we can verify that by going to our team site, and that is in fact the title of our web. So that worked. So we just made a call using the client-side object model. It called into the client.svc endpoint on SharePoint. We didn't have to do that, but the client object model did that for us. So let's do this now. Let's go ahead and set a breakpoint here on the load method. And I'm going to press F5 to start debugging. And I'm going to examine web. And you'll notice that none of these properties have any values. In fact, server version is throwing an exception. And the exception here is the property or field has not been initialized, has not been requested. See if I can make that bigger. Let's just copy the value. Has not been requested, or the request has not been executed. It may need to be explicitly requested. That's because we haven't gotten that far yet. So now we'll go now we've loaded it, and if we look at the properties on it, we're still going to get that exception. See, all these are throwing exceptions here because we haven't actually gone to the server yet. So after we call execute query, now if we go to the web, now we have properties. Everything's filled out now. Some of them still are throwing exceptions because we haven't requested those. We only requested web. But you can see if I go, let's go down to description, I can see that. Language, last time was modified. So you can see it's a few simple steps that you have to do, but it sure does make it a lot easier than building your own wrapper around those web services. So the demo that I just did shows the basic use of the client context class. Client context is a subclass of the client runtime context that is governing the communication with the server. So you provide the context by providing the URL to your SharePoint site. And then from the context, you gain access to instances of the site and web classes. And when you establish a context, you can specify both the authentication mode and the credentials required by the SharePoint site. Now in this case, in the console application, I didn't do that because I was on the same machine as the server, and so I was currently logged on as a user that's part of the SharePoint site. So I didn't have to do anything with that. But you can pass in credentials. So if you wanted to, you could pass in an instance of the network credential class. So with a username and a secure password, and then you would just attach that credentials, the instance of your network credential. There's a credentials property on the context, on the client context. Or in case you were going against SharePoint Online, there's a special class for SharePoint Online called SharePoint Online Credentials. Once you've authenticated, you decide how much of the object graph that you want to load. and then you don't actually submit all of your requests individually. So what happens is, until you call execute query method, whatever actions you've done gets submitted as a batch. So batching operations is one key to minimizing the network traffic. Another one is retrieving only the information that is required to perform an operation on the client. So if you're only going to be working with one list, then you don't need to load up 5 other lists. Just load up exactly what you need, and then that way it's going to reduce the payload going across the network. And normally you're just going to get simple reference types and not the child collections. And then each call that you add is going to add a query to your batch. You could actually load a specific list item without even having to load the list itself. That is great, because then that's going to reduce the amount of traffic going over the network, which is going to make your app a lot faster. So once you have the complete batch of objects to load, the way you get that to the server is you call execute query. And what that's doing basically is that's making that web service call to the client.service endpoint. So execute query can be a synchronous operation and populates objects from the load T method, and also persists updates on the server. So now we'll take a look at loading and reading lists using the client-side object model. We're going to go back to our example in the console application that we've created, and we're going to load a list. So I'm going to delete these 2 lines here, and let's put a list in here. I'm going to go grab the announcements lists. And I'm going to verify that site has an announcements list. It does. Let's just add an item to it. Save that. Okay. Now I'm just going to F5 this, and I should get an exception. Yes, I did, because the collection has not been initialized. So now let's change this call here. Get by title. And let's run this now. So this time the code ran, and we can verify that it runs because we'll put a breakpoint on read line. So it ran fine, but if I hover over announcements, you can see that we're not getting anything because none of its fields have been initialized yet. And the reason why this is because we didn't use load and we didn't use execute query. So you can still invoke methods, but you're not going to get any data out of it. So now we'll change this code again. And I'm going to get rid of, I don't need to load the web anymore, so I'm going to get rid of that. And let's do call context dot load, and let's just only load the content types of the announcements list, and then we'll execute that query. And then let's write out the properties of the first content type. Okay, I'm going to put a breakpoint right here where we try to write out the, actually I'll put the breakpoint here. So let's run this, and our console window is showing that we got the name of the first content type because we loaded the content types, but now we're going to try to load the title, and this should fail on us. And that's because it hasn't been initialized. Because we didn't tell it to load the announcements list itself. That's not going to work. It's not initialized. So that shows how to just basic loading up of a list. Now we could actually change this. Let's run this again. And see, now we're not getting the content types because we didn't tell it to load the content types. So if I comment this out, run this again, now we're getting the list of announcements. So you have to be careful about what you choose to load and make sure that you have that done before you call execute query. That you're loading the correct things and you're calling execute query to get the data out of the list. Actually getting anything out of SharePoint using the client-side object model. So the previous demo that I just did, I loaded up the entire announcements list, and it's pretty wasteful. Sending the entire instance over the wire is very inefficient. There's a better way to do that, and the way to do that is by using lambda expressions to filter the results. So we can pass in a lambda expression to the load method, and then that's going to allow us to only retrieve what we want. So in this demo, we're going to take a look at loading list properties, specific list properties, using lambda expressions. Okay, switching back to the console application now, and I'm going to change up some code. We're going to load our web again, but this time we're only going to load the properties that we want. Oops, I meant to say context.load. And this time we'll use a lambda expression. So we're using the lambda description here to only load the properties that we care about, and we can just see here it's allowing us to put in multiple lambda expressions, which is nice. It's using params keyword, so we can load in multiple lambda expressions. And so now we've got our load in. Now we can execute query, and let's do a write line here. copy this. We'll print out the title and the description of the website. And let's just put something into the description of the website. So let's go to site settings, title, description, logo, and we'll just say welcome to my team site. Close that down. So now we'll put a breakpoint on read line, we'll run this. And you can see we're getting the data out. The only data that was sent across the wire was the ones that with the properties that we cared about. Actually, let's run this again. And I'm going to hover over web. Go drill into its properties and notice how, so I can go to description. Description is there. Go down to title. Title is available. But a lot of these other ones are throwing exceptions because they haven't been initialized yet. Again, we're only getting back what we requested. So let's try something a little bit more interesting here. This time, I'm not going to load anything. Let's get rid of these. Let's make some changes to our web. We'll change the description. And just like in the regular SharePoint server model, whenever you change one of the main core objects in SharePoint, you have to call update on it. All this does is just telling client-side object model that we're doing an update. I'm actually going to leave this in here. We'll keep that on there. And we'll run this. And now we'll check our site. And notice how the quick launch on the left-hand side is not there anymore. And let's go to site settings and see if our description has changed. And it sure has. Here's what we told it to have. We'll go ahead and put quick launch. Actually, it's probably easier just to let's close this down, set this to true, just run that again. Open our site back up, and our quick launch is back. And let's go ahead and try this without loading context, without loading the web. Let's make this false. Let's run this again. And we'll see if our quick launch is there. And it's not. Let's make it true so we have it for later. Quick launch is back. So what I just did there, we're not loading any properties up. All we're doing is making updates. So we don't need to load any property. We're just sending updates across the wire. So we don't need to load any data up here. So all we're doing is sending a command to the web service on the SharePoint end just to, in this case, we're going to enable quick launch and then change the description. And then the web service that's receiving this makes the translation and calls the correct server-side API to carry out these operations. So filtering with lambda expressions works well for simple properties, but isn't sufficient for dealing with collections of objects. So When working with collections, you need to limit the result to prevent loading a large number of items when you only need a small subset. And you can filter collections with LINQ. And the way we do it, one way is to use the client object queryable extension .include method, and that's going to return an iQueryable instance. And what that does, that method that returns iQueryable allows us to chain query expressions like a where clause. So this chaining can use it on collections, and we can actually load a specific subset of a collection where some condition qualifies the item for inclusion in the result set. But it's not a substitute for camel queries. So when you do this and the client service executes your code on server, even though you've told it you only want back a subset, that's just for coming across the wire. On the server side, it's actually going to enumerate the entire collection to build what you requested in the return list. But with a camel query, that's actually more efficient on the server side as well, because it's only going to get the matching items from the content database. So both of them will return what you want over the wire, but the camel is actually more efficient on the server side by not using as much resources to get the data from the content database. So the client context.load query method is an alternative to the load method that you can use when you work with collections. Differences being the syntax and the return type. So load query uses LINQ query syntax, whereas load uses method syntax. The difference is not the reason why you would choose to use load query, because we saw before you can use the include extension method to use LINQ with the load method. But the reason why you would use load query instead of load is because of the different return type. So load returns an object collection of SharePoint types, so it could return something like a list collection, whereas load query will return a new instance of IEnumerableT. So if you're making heavy use of link to objects, then you're going to prefer the more generic IEnumerableT, since you have lots of different LINQ extensions you can use off the IEnumerableT. And again, once we get that IEnumerableT, then we're able to do anything that we could do with regular link to objects. So doing our selects, we could do .where, all the extension objects apply to it. So what we're going to look at now is filtering list query results with LINQ. So I'm going to go in this, I'm going to demonstrate the load method first. So we'll get a list collection of lists. And we'll load these lists up. So we'll load the list up where the title the base type equals generic list. Then we'll execute the query. and then we'll print the results out. Okay, we'll go ahead and run this. Actually, we can comment all this stuff out. Okay, so here's all of our lists that we have where the base type is generic list. That's using the load method. Now what I want to do is I want to use load query, and we'll see how these are different. This time I'm going to get back an IEnumerable of list instead of just a list collection. And because I have an IEnumerable, I should be able to do doclabs dot. Nope. So now we're going to iterate through the document libraries and print them out to the screen as well. So we'll go ahead and run this now. We forgot to load. Okay. Let's do this again. Actually, we don't need to do that. What we forgot to do, we forgot to call context to execute query. Number one most important thing to do for using your code, you have to execute your query. And actually, let's put a right line here. So now you can see we're getting our document library. So we can see the difference here. We're calling context.load. We're loading up a list collection here. And in this case, we're calling context.load query. this case, we're getting back all the document libraries. So context.loadQuery is giving us back IEnumerable list of document libraries, whereas the context.load doesn't return anything. It's just a void, but load query is going to give us, returns that IEnumerable back so we can do things with it. So in this case, we could have done some other operations on the IEnumerable. So if we go to so whatever operations we could do with the IEnumerable, we could have done right here. We didn't do any, but we could have definitely done something there with those. Could have done other where calls on it if we wanted to.